Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session. You are watching us on our PMeVIDYA channel number 8 and also on our YouTube channel ncertofficial. जी हाँ, आज हम क्लास 8 के हमारे स्टूडेंट्स के लिए साइंस सब्जेक्ट के अंतर्गत एक टॉपिक लेकर आए हैं which is chapter 11 of your text books. और चैप्टर का टॉपिक है या टाइटल है केमिकल इफेक्ट्स ऑफ इलेक्ट्रिक करंट. हम जानेंगे कि किस तरीके से इलेक्ट्रिक करंट का जो केमिकल इफेक्ट देखने को मिलता है, कैसे वो प्रोड्यूस होता है. हम ये सब चीज़ें सीखेंगे और भी बहुत कुछ, क्योंकि कुछ डेमोन्स्ट्रेशंस भी होने वाले हैं इंटरेस्टिंग से. सो देयर इज़ अ लॉट वेटिंग टू कम योर वे और इसलिए बहुत ज़्यादा ज़रूरी है कि आप बहुत अटेंटिव रहें, आप पार्टिसिपेट करें सेशन में, क्योंकि सेशन लाइव एंड इंटरैक्टिव है. इस वक्त आप हमें लाइव हमारे यूट्यूब चैनल ncertofficial पर भी देख रहे हैं. तो सबसे पहले आप नोट कर लें हमारा फ़ोन नंबर विच इज़ 8800440559. कोई भी आपके क्वेश्चंस हैं सेशन के बीच में, अगर आप कुछ पूछना चाहते हैं या फिर बाद में आपको लगता है कोई फीडबैक देना चाहते हैं, तो आप हमें ईमेल लिख सकते हैं. ईमेल आईडी है dth.class8@ciet.nic.in. और जैसा कि मैंने आपको बताया कि YouTube चैनल YouTube NCERT Official पर आप हमें देख रहे हैं. So what you can do, you can always go to the comment section, put in your questions there, drop your questions, comments, suggestions there और आप हमसे instantly connect कर सकते हैं. और आज के सेशन में केमिकल इफेक्ट्स ऑफ इलेक्ट्रिक करंट पर हमें पूरी इन्फॉर्मेशन देंगी हमारी एक्सपर्ट हु हैव जॉइंड अस इन द स्टूडियो. वी आर जॉइंड बाय मिस प्रीति मान. लेट्स वेलकम हर. मैम नमस्कार, वेलकम. सो मैम इज़ TGT साइंस और मैम के साथ हम इस कॉन्वर्सेशन को आगे बढ़ाएंगे. लेट्स सी व्हाट ऑल शी हैज़ ब्रॉट फॉर अस. बट सबसे पहले मैं मैम से रिक्वेस्ट करूँगी कि मैम प्लीज़ आप हमें बताएं कि आज के सेशन में एग्जैक्टली हमारे लर्नर्स व्यूअर्स क्या सीखेंगे और लर्निंग आउटकम क्या रहेगा.
ओके, इलेक्ट्रिक करंट इज द टॉपिक विच स्टूडेंट्स आर स्टडिंग फ्रॉम ग्रेड 6. सो पहले वो हीटिंग इफेक्ट पढ़ते हैं, देन मैग्नेटिक इफेक्ट पढ़ते हैं. ग्रेड 8 they'll be studying about chemical effects. So wherein they'll come to know about new terms.
Okay.
So chemically when a reaction takes place, so what all thing happens.
Okay.
So these are the few topics that we'll be covering today in the session.
Sure ma'am. So ma'am जो टॉपिक है वो भी काफ़ी इंटरेस्टिंग है, केमिकल इफेक्ट्स ऑफ इलेक्ट्रिक करंट. नाउ बिफोर वी गो इनटू द डेप्थ कि हम इफेक्ट्स को समझें, लेट्स ट्राई टू अंडरस्टैंड कि इलेक्ट्रिक करंट एग्जैक्टली क्या होता है.
Electric current, if we go by definition, so electric current is what? It is flow of electric charge. So in a circuit, when electric charge flows, electric current is produced.
Okay.
And we have seen all the appliances, they just work on a click. So we just turn on the button and the appliance is working. So what exactly happens? The circuit is closed, the current flows and the appliance is working. So that's how it is defining that flow of an electric charge through an electric circuit.
Okay.
It's defined as electric current. Now next we'll see that what happens when electric current passes through the circuit. So like I've told you that electric current passing through, it shows heating effect, it shows magnetic effect and it shows chemical effect.
Okay.
So one by one we'll pick them up and before that there are certain terms that we'll keep in mind.
Absolutely.
A kind of revision.
Okay.
So the terms are easy but important. So what do we mean by conductors and insulators? So conductors, they are the substances which allow electric current to pass through them. So why is that happening? We'll see it.
Okay.
Next is insulators. Now they are the substances that does not allow electric current to pass through them.
Okay.
Okay, so we have a short demonstration right now to identify between the materials which are conductors and which are insulators.
Right. So you have prepared some demonstration also.
Yes.
So let's just go through the theory, or you're doing the practical right away?
Now I'll do the practical right away. Theory we have seen, that's the definition. So by using these simple materials, we have created a circuit over here.
Okay.
That's a battery and these are the connecting wires and there's a bulb. So we have seen in the definition previously that conductors are the substances which allow electric current to pass through them.
Yes.
So, we have certain materials present with us. That's a safety pin, copper wire,
Okay.
eraser, and this is a plastic
Cap.
cap,
Okay.
and there's a wire.
Okay.
Now, we'll test one by one. So, now how this circuit works, if the material is conductor, any of these material, if it is a conductor, then this bulb will glow.
Okay.
Because they allow electric current to pass through them, right? So, is it visible?
Yes, the bulb glowed up.
Yes.
Right.
So, why that happens? Because the material is allowing or letting the electric current passing through it, because it has got those charged particles present inside it. Now, this is done. This is a conductor.
Okay.
Now, next we'll test with an eraser.
Right.
So, touching it,
Nothing happened.
nothing is happening, right? So, how we'll classify it as? This is a
Insulator.
insulator. Next, this pen cap, nothing happening again.
Yes.
So, this is
Insulator.
insulator. Now, next we have this copper wire.
Okay.
So, what do you think will happen here?
I think if it's a conductor, it will glow up, and let's see whether it's a conductor or an insulator.
Yes. So, we'll join in the ends and see what happens in the circuit is shaking. Okay, we have one more copper wire present in here. We'll test with that.
Okay. Yeah, so the bulb is glowing up.
Yes. So, there must be some issue with the earlier copper wire.
So, in all, we can say that copper is a good conductor of electricity.
Yes, it is. Now, see the same wire, the outside covering, if we see and try to do this conduction test. So, the bulb is not glowing.
Yes.
Now, this gives us the answer to the question why insulation is required.
Right, right. It's
Right?
just for the safety purposes sometimes,
Yes.
you know.
So, if we are handling the electrical devices, we need so that the person is not getting electrical shock,
Yes.
and if it is any utensil, then we need it so that the user doesn't get that heat effect.
Right. Now, this was an excellent demonstration, and we have seen clearly that conductors, you know, let the electricity flow through them, and insulators, of course, they totally restrained it. Now, I have this question, you know, like if the circuit is properly all right, is working well, in good condition, are there any possibilities that still the bulb won't glow up?
Okay, there are certain possibilities for that also. See, our circuit, it was working well.
Yes.
Because the bulb was glowing.
Yes.
But if in a circuit the bulb is not glowing, it shows that the circuit is not working properly.
Okay.
Okay. So, the reason could be the bulb that you are using, the filament is broken. Right?
True. Yes.
Second, the battery that you are using, it may be used up.
Right.
So, these are the possibilities that can occur why if you have made all the necessary arrangements and still the circuit is not working in a right condition.
All right. Okay. So, now let's move ahead.
Yes. Now, electrical conductivity of solids we have seen right now. So, these are the examples mentioned here, that copper, steel, iron, aluminium, and certain materials that has got free electrons present in them.
Right.
They are good conductors, and the ones that doesn't have free electrons present in them, they are considered as insulators. Now, this we have talked of solid. The same goes with liquids also. So, there are liquids that conduct electricity, and there are liquids which do not conduct electricity. Now, here again the circuit is shown on the screen.
Okay.
So, the conducting liquid shows the bulb glows, and for the non-conducting liquid the bulb doesn't glow.
Okay.
Examples we can take it, the tap water is a conducting liquid,
Okay.
but distilled water is not.
Oh, okay.
Right?
Right.
Distilled water, the one that we use in the batteries, that is non-conducting, but tap water, it conducts electricity. Any guesses what could be the reason for that?
Maybe I think distilled water is diluted or something. I really don't know. You have to make us understand.
It is basically the presence of those dissolved salts present in them. Right?
Right.
So in examples, if we see good conductors of electricity, the liquids that are conducting, examples mentioned are tap water, salt solution, hydrochloric acid, sodium hydroxide. So basically the solutions of acid, bases and salts.
So it means we can say that, I mean, alcohol, is it a conductor, a good liquid?
Alcohol is not a good conductor.
Okay.
I'll make you understand because it is a bit confused.
Yes.
Base, because alcohol has that OH group in the end, but it is not considered as a base.
Because they show, you know, in the movies that you have thrown the alcohol and suddenly it flared up or something of that sort happened.
Because that's the different reason. It is inflammable.
And what about perfumes?
Perfumes, they are inflammable.
Okay.
Yeah.
All right.
They are inflammable, they catch fire. Now herein, the solutions of acid, the simplest of acid, if we take in like HCl. So HCl has H plus and Cl minus ion present in it.
Yes.
Same as base, if we take in NaOH, that has got Na plus and OH minus ion present in it. Salt, common salt, everybody knows the formula is NaCl. So therein Na form Na plus and Cl form Cl minus.
So positive, negative charges there.
Yes. So all these acid, bases and salts, when they are dissolved in water, they break into their respective ions.
Right.
And that's the reason why they make the solution conducting.
Right. Okay.
Now, again, if we see the examples for the poor conductors like distilled water, there is nothing present in distilled water, it is pure form of water, no dissolved salts, nothing is present.
Right.
Sugar solution, so sugar, it is not an ionic compound, kerosene, oil it is, spirit again. So, these all examples, distilled water, sugar, kerosene and spirit, they are not having ions present in them.
So kerosene and spirit, though they are inflammable but not good conductors of electricity.
Yes. So if the same test is being done with the liquids, so the one which are conducting, in that case the bulb will glow.
Okay.
And the non-conducting liquids, the bulb won't glow there.
All right.
And the conducting liquids, there is a term we use for them, they are called as electrolytes.
All right. Okay.
Now moving ahead is the second property, that electric current also produces magnetic effect. So when electricity is going around in the circuit, what do we see? If we keep a compass, so the compass needle will show a kind of deflection there.
Oh, okay.
And there are many applications to it that we are using this magnetic effect of electric current. We use it in making solenoids, electric bell, it has it.
All right.
Then electromagnets. So how they work, if you put the electric current on, if the circuit is closed and electricity is passing through it.
Okay. So, ma'am, are there like any specific areas where we can apply the magnetic effect of electric current?
Yes, that's what I was explaining.
But also apart from these, just there's a confusion, you know, during a sea voyage, people use these compasses. So, are they kind of working on this electromagnetic thing?
See, Earth has its own magnetic field. We have a North Pole and we have a South Pole.
Yes.
And we even has that pole star that shows us
the direction. Yes.
So, the compass also, the needle when it deflects, it takes you towards the north direction and accordingly you will find the directions.
Okay. All right. Okay. So, let's move ahead then.
Now, next, the final topic that we have here, it is chemical effects of electric current. So, what happens at chemical level when electricity is passing through a conducting solution?
Okay.
Conducting solution, we have seen it has to have an acid, a base or a salt.
Okay.
Okay. And what happens exactly when electricity is passed through an electrolyte? What do we see? Either there will be formation of gas bubbles at the electrodes.
Yes.
Now, electrodes here, the one connected to the positive one we call it as anode,
Anode.
and the one connected to the negative terminal of the battery, that is called as cathode.
Yeah.
Either will see the metal gets deposited on the electrode. So this second point has so much of application to it. Next is we see change in the color of the solution. So any of these observations, if they are found, so we say that yes, something has happened at the chemical level,
Right.
and it is showing us the chemical effects of electric current.
Okay.
To show that, we have this process called electrolysis of water. Now we'll just pick up the name. It is electrolysis. Lysis means breaking something,
Okay.
with the help of electricity, right? So when electricity is passed through water, we know the formula for water is H2O.
Yes.
So when electricity passes through water, then what happens? Water decomposes into hydrogen gas and oxygen gas.
Okay.
So over these electrodes, one of the electrodes will have hydrogen gas coming out, and the another electrode will have oxygen gas coming out to it.
So ma'am, how to identify that which gas is liberated from which electrode?
Yes. So if we see the whole equation,
Okay.
it is H2O giving out H2 plus O2. That is happening. This equation is not balanced. So for balancing it, we have to do it as 2H2O
Okay.
giving us 2H2 plus O2. So with this we know that the amount of hydrogen that is coming out, it is more as compared to the oxygen gas,
Okay.
because it is 2H2
Yes.
plus O2.
Okay.
Now hydrogen gas will be liberated at cathode and oxygen gas will be liberated at anode. Now further we can collect the gas and do the confirmatory test.
Okay.
Hydrogen gas, it burns with a pop sound, and oxygen gas, it brighten up the flame.
Okay.
So
All right.
that's how we are able to identify,
yes.
that over which electrode which gas is
getting
released.
liberated. Right. Okay.
Now next we have the application of electrolysis,
Okay.
that is electroplating. Overall, what is happening in this process, that a desired metal, it gets coated over some cheap metal, say. So if you want to electroplate, say, gold over the jewelry, so we can take small amount of pure gold and connect it to the one terminals, and the jewelry that you want to electroplate, that can be kept on the other terminal.
Okay. Okay.
And I'll quickly show this process to you.
All right. So we
So
have
what-
another demonstration.
Yes. So in this, though we are not using gold, we'll use copper sulfate.
Okay. But students can practice at home
Yes.
if at all they have any precious metal.
So what we have taken in here, this is copper wire, pure copper wire.
Okay.
Now we want this coin to be electroplated with copper. Okay. So one terminal is our pure copper wire, the second terminal is this coin that we want to electroplate.
Okay.
We have this beautiful blue colored salt. This is copper sulfate, also called as blue vitriol, and we have made its solution.
Okay.
Now this is acting as an electrolyte, liquid that conducts electricity.
Okay.
Yes. Now what we'll do here is, we'll connect, see, battery, you need to properly see that which terminal you are connecting it to. So this is the positive terminal and this is the negative terminal. Referring to the figure, if we say that, so the positive terminal, we need to attach the pure metal,
G.
and towards the negative terminal,
Yes.
we'll attach the material that we want to electroplate.
Okay.
So connections are made here. Now we'll dip the solution in the electrolyte.
Okay.
So meanwhile this process is taking place, I'll quickly explain
Yes.
you what happens. I just have to hold it.
Yes.
See, the moment both the electrodes are dipped into the solution, the very first thing that happens is electricity passes through. The electrolyte is copper sulfate. So copper sulfate, it breaks into its respective ions, that is copper and sulfate.
Okay. Sulfur.
Yes, sulfate.
Sulfate.
Sulfate
Okay.
is SO4.
Okay. Okay.
So it is Cu2 plus, one ion will be formed and SO4 2 minus.
Okay. All right.
Now copper ion that is formed here is positively charged. And we know that opposite charges, they attract each
Yes.
other. So positive charge copper ion will move towards which electrode?
-1.
Negative electrode. And what we have kept on the negative electrode?
The coin.
The coin, right? So from the solution, the copper ions will move towards the negative electrode and get deposited over it.
Okay.
What will happen? There will be less amount of copper ions in the solution. To compensate for the same, equal amount of copper ions from the positive terminal or from this copper strip will move to the solution, right? So it is solution to negative electrode, the ion becomes deficient, and from the positive electrode to the solution.
And at the same time, it is not advisable to put your finger in the solution right now.
Yes, it is
because
not.
you can get electrocuted.
It is not.
Okay.
So you can wait till the time the process takes place and we can check whether some of the reactions have occurred here or not. So, yeah.
Yeah, just put it in the center, ma'am, so that everybody, yes. Like
See,
this.
the color of this pen, if you can check in here, it has turned brown.
Yes, I can see that clearly.
We have kept it for less time, that's why the coin is not completely brown.
Yes.
Rather, the pen which is holding the coin, it turned brown.
Yes, because we are sitting in close proximity, we can say that it has turned brown, but when you will perform the experiment at home or under the supervision of some teacher of yours, you will also see it getting brown. So that means it has been electroplated.
Yes.
Okay. So ma'am, now we are left with only 2 more minutes. So is there anything else that you would like to explain very quickly?
Quickly we'll cover up that what are the uses of electroplating, where all we use it. So I've told that if you want to take some precious metal and coat it over a non-precious or semi-precious metal, that can be done. Now applications are mentioned here. Chromium has shiny appearance and it does not corrode.
Yes.
So chromium plating can be done on the objects like bicycles, car parts, tap, gas burners, jewelry making.
Yes.
Then we can have tin cans that is used for storing food. It is electroplated over iron because iron rust.
Yes.
And then iron objects, they are even coated with zinc. That process is called as galvanization to prevent it from corrosion.
Right. So that was our session for today. Very interesting one, very informative, and along with some practical applications that ma'am showed us here. So for this entire session and this wonderful explanation, I would like to thank my expert. Thank you so much, ma'am, for being with us and for your unique contribution to the session. Now viewers and students, it's time for me to wrap up the session over here. But before I leave, let's take a look at the live schedule. What all programs are coming up in front of you. Let's have a look at the same. In a short while from now, you can watch another session of ours which will be on mathematics, title, direct and inverse proportions, followed by our online training program that will be conducted in Hindi. This is the 4th day. This will be followed by Sahyog, where we will be talking about understanding and valuing diversity through festivals. With this, it's a wrap. This is me, Harpreet Kaur, taking leave of you. Plus, you have to stay tuned with us because a lot more informative and educational programs are coming your way.